beneath the night sky, a pale river of light stretches from horizon to horizon. It appears faint and delicate, easily lost beneath city glow, yet it is vast beyond comprehension. Every soft grain of light belongs to a single structure, a rotating island of stars, gas, dust, and unseen mass. This is the Milky Way, not as a distant object, but as the environment itself, the galaxy in which everything familiar has always existed. For most of human history, this luminous band was a mystery without edges. Ancient cultures traced stories through its glow, seeing paths, rivers, and celestial realms, long before its true nature was understood. Even now, despite centuries of observation and exploration, the Milky Way resists simple explanation. It cannot be photographed in full, cannot be stepped outside of, and cannot be grasped in a single view. It must be understood by motion, by inference, and by time. Every visible star in the night sky is part of this galaxy. They are not scattered randomly, but bound together by gravity into a vast rotating system. Between them lies an interwoven medium of gas and dust, the raw material of future stars, drifting through immense distances. Invisible matter surrounds and penetrates the galaxy, shaping its motion and holding it together, even though it cannot be seen directly. What appears calm and unchanging from Earth is in fact in constant motion. The Milky Way is neither small nor exceptional by cosmic standards, yet its scale defies intuition. Light itself takes many thousands of years to cross its disk. Entire civilizations could rise and fall while a single star completes only a fraction of its journey around the galactic center. Time behaves differently on these scales, stretching beyond ordinary experience. This journey begins close to home, within the quiet outskirts of the galaxy, where a modest star and its planets drift along a stable path. From there, the route leads outward through neighboring stars, through regions of stellar birth and death, along spiral arms heavy with gas and light, and inward toward the dense sphere and turbulent core. Each region reveals a different aspect of the same vast structure, shaped by gravity, motion, and deep cosmic history. The Milky Way is not a static backdrop. It is a living system, growing through collisions, shaped by ancient events, and slowly changing over billions of years. To move through it is to move through time itself, tracing the long story of how stars form, how galaxies evolve, and how a quiet corner of this immense structure came to host a small world capable of looking outward and wondering. From this point onward, distance will steadily lose its familiar meaning, and scale will expand beyond anything encountered before. The journey through the Milky Way is not measured only in light and motion, but in perspective, revealing how vast the galaxy truly is and how small any single point within it has always been. Beyond the faint glow of the Milky Way as it appears from Earth lies a region shaped by a single ordinary star. This star, modest in size and brightness, anchors a small system of planets, dust, and ice. Compared to the galaxy that surrounds it, this system is fragile and small, yet it exists within a carefully balanced pocket of space, protected from much of the chaos beyond. Encasing this system is a vast magnetic bubble formed by a steady outflow of charged particles. This invisible boundary stretches far beyond the outermost planets, deflecting much of the high-energy radiation that drifts between the stars. It is not solid nor permanent, but it provides a subtle shelter as the system moves through the galaxy. Beyond its outer edge, the influence of the home star weakens, and interstellar space begins to assert itself. This surrounding region is not empty. Thin clouds of gas drift through the darkness, mixed with dust grains and high-energy particles moving at near light speed. These materials are the remnants of long-dead stars and the raw ingredients of future ones. They form a diffuse medium that fills the spaces between stellar systems, shaping how galaxies evolve over time. The passage from the inner sanctuary of a star system into interstellar space marks a profound transition. Speeds that once seemed extreme become insignificant. Distances expand until familiar units lose their meaning. The nearest neighboring stars are no longer hours or days away, but separated by gaps so large that light itself takes years to cross them. Drifting outward from this quiet region, nearby stars begin to appear not as isolated points, but as members of a loosely bound neighborhood. These stars move together through the galaxy, each following its own path while sharing a common orbital flow around the galactic center. Some are similar in size and temperature to the home star, while others are smaller, dimmer, and far more numerous. Many of these faint stars burn slowly, conserving their fuel over immense spans of time. Their light is weak, often invisible to the unaided eye, yet they dominate the stellar population of the Milky Way. Around some of them, planets circle closely, locked into tight orbits where days last only a fraction of those experienced closer to home. In these systems, gravitational forces are strong, tides are extreme, and conditions shift in ways unlike anything familiar. As distance increases, individual stars begin to blur into patterns. Constellations lose their familiar shapes as perspective changes. Stars that appear close together from Earth drift apart, revealing the depth of space between them. Motion becomes apparent on timescales that once seemed static, as stars trace slow arcs across the galactic backdrop. This local neighborhood is only a thin slice of the galaxy, a minor feature within a structure that spans vast distances. Yet even here, the Milky Way reveals its first hints of scale and complexity. Each star carries its own history, formed from material enriched by generations of stellar life and death. Together, they mark the beginning of a journey that moves steadily outward, away from the quiet margins and toward regions where the galaxy grows brighter, denser, far more extreme. As the distance from the familiar star systems increases, the Milky Way begins to reveal a different character. The darkness between stars is no longer uniform. Wisps of gas stretch across space in faint, uneven threads, barely visible yet vast in extent. These clouds drift slowly, shaped by gravity and radiation, carrying the chemical traces of ancient stellar explosions. Every heavy element within them was forged in the heart of a star long ago. Some regions grow brighter as massive clouds collapse under their own weight. Here, gravity gathers material into dense knots, heating it until new stars ignite. These stellar nurseries glow softly, their light filtered through surrounding dust. Within them, hundreds or even thousands of stars may form together, bound briefly by gravity, before drifting apart over millions of years. What appears serene from a distance is a place of intense motion and transformation. Not all stars live quietly. The most massive burn fiercely, consuming their fuel at a tremendous rate. Their lives are brief on cosmic timescales, ending in violent explosions that scatter material across vast regions of space. These supernovae send shockwaves through nearby clouds, compressing gas and triggering new rounds of star formation. In this way, destruction and creation are inseparable processes woven into the structure of the galaxy. Moving farther along the galactic plane, the density of stars steadily increases. Points of light multiply until the background itself seems to glow. Here, stellar paths are crowded, and interactions become more common. Radiation levels rise, and gravitational influences overlap. These regions are rich in energy but hostile to stability, places where planetary systems struggle to remain intact over long spans of time. Amid this growing complexity, patterns begin to emerge. Stars are not arranged randomly, but trace vast curving structures that wrap around the galactic center. These spiral arms are marked by young, bright stars and dense clouds of gas, outlining the shape of the Milky Way from within. They are not fixed structures, but waves of density moving through the galactic disk, gathering material as they pass. Between these luminous arms lie quieter regions. Here, star formation slows, and older stars dominate. These calmer zones provide relative stability, allowing planetary systems to persist over billions of years. The position of the home star within one of these regions is not accidental. It reflects a balance between the galaxy's dynamic forces and the long timescales required for complex processes to unfold. As motion carries this journey onward, the scale of the Milky Way becomes increasingly apparent. The galaxy is not merely a collection of stars, but a rotating system shaped by forces acting across immense distances. Every star follows an orbit influenced by the combined mass of visible matter and a vast halo of unseen material extending far beyond the luminous disk. This invisible component exerts a quiet but decisive influence. Without it, the galaxy would not hold together as it does. Stars would drift apart, and the spiral structure would dissolve. Instead, the Milky Way remains coherent, its form preserved over billions of years by forces that cannot be directly observed, yet are felt everywhere. With each step deeper into the galaxy, the sense of motion intensifies. Orbits tighten, velocities increase, and time itself seems to compress. The journey continues inward, toward regions where gravity dominates more completely, and where the true heart of the Milky Way begins to exert its influence. The inward path continues through regions where stars grow older and more densely packed. Here, the light takes on a warmer tone, dominated by long-lived stars that have circled the galaxy many times. Their orbits are steady but not perfectly aligned, rising and falling slightly above and below the galactic plane. Over immense spans of time, these subtle motions thicken the disk, giving the Milky Way its layered structure. Far above and below this disk lies a vast halo, extending hundreds of thousands of light-years into space. It contains sparse stars, ancient clusters, and an enormous reservoir of invisible mass. These halo stars move along elongated paths, plunging toward the galactic center before arcing back into the darkness. Many are relics of smaller galaxies consumed long ago, their original structures erased, but their stars still tracing ghostly orbits around their new home. Among the oldest objects in the galaxy are dense spherical gatherings of stars known as globular clusters. Each contains hundreds of thousands of stars packed tightly together, bound by gravity into stable formations that have endured since the earliest epochs of the AI, Milky Way. Their stars are poor in heavy elements, formed before the galaxy was enriched by countless generations of stellar explosions. These clusters act as fossils, preserving a record of the galaxy's distant past. As the journey moves inward, the spiral arms grow more complex and luminous. Gas clouds thicken, and star formation becomes more intense. Radiation from young stars sculpts the surrounding material into pillars, arcs, and cavities. The interplay between light and shadow creates vast cosmic landscapes, constantly reshaped by gravity and energy. In these regions, time moves quickly on stellar scales, as massive stars blaze briefly before fading or exploding. Closer still to the center, the galaxy takes on a barred shape. A dense stream of stars stretches across the core, channeling gas inward along elongated orbits. This central bar plays a crucial role in feeding the inner regions, guiding material toward the heart of the Milky Way. Stars here move along intricate paths, their motions influenced by overlapping gravitational forces that create a complex and dynamic environment. The density of stars increases dramatically near the core. Distances that once spanned light years now shrink to fractions of that scale. Stars pass relatively close to one another, and the gravitational influence of the central mass becomes unmistakable. Motion accelerates, and orbits tighten into rapid arcs around a common focal point. At the very center lies an object defined not by light, but by absence. A compact region of immense mass anchors the galaxy, shaping the motion of everything around it. Though it cannot be seen directly, its presence is revealed through the behavior of nearby stars, which race around it at extraordinary speeds. Their paths trace tight loops, responding to a gravitational pull unlike anything found elsewhere in the galaxy. This central mass exerts its influence far beyond its immediate surroundings. Gas clouds drawn inward heat up and emit powerful radiation, briefly illuminating the region before disappearing beyond a boundary from which nothing returns. Despite its formidable nature, this core is relatively quiet, consuming material slowly, allowing the galaxy around it to remain stable. From this turbulent heart outward, the Milky Way holds together as a single rotating system. Every star, cloud, and cluster is linked by gravity to this central anchor. The journey through these inner regions reveals the galaxy at its most intense, a place where extremes of density, motion, and energy coexist, shaping the long-term evolution of the Milky Way itself. Beyond the immediate influence of the central regions, the Milky Way reveals layers that are less luminous, yet no less important. Surrounding the bright disk and dense core is an enormous envelope of hot, diffuse gas. This extended halo stretches far into intergalactic space, faint and nearly invisible, yet massive enough to rival the combined weight of all the galaxies. Stars. It acts as both a reservoir and a boundary, interacting slowly with the wider cosmic environment. Within this halo, streams of stars arc gracefully across the darkness. These stellar rivers are the remnants of smaller galaxies torn apart by the Milky Way's gravity. Over billions of years, such mergers have quietly reshaped the galaxy, adding mass, altering orbits, and thickening its structure. Though their original forms are gone, the stars they contributed still carry subtle chemical signatures that betray their distant origins. The history of the Milky Way is written in these motions. By tracing the paths of stars and clusters, astronomers can reconstruct ancient collisions and long-forgotten encounters. Some stars move against the general rotation of the disk, others plunge through it on steeply inclined paths. Each trajectory is a clue, pointing to events that occurred when the universe itself was far younger. Deep within the halo, dark matter dominates completely. This invisible substance outweighs all visible matter many times over, forming a vast framework that extends well beyond the luminous edge of the galaxy. It does not emit or absorb light, yet its gravitational influence governs the motion of stars and gas alike. Without it, the Milky Way would lose its shape, its stars drifting away into intergalactic space. The presence of dark matter is inferred through motion. Stars orbit the galaxy faster than visible mass alone can explain. Gas clouds move as if pulled by something unseen. The galaxy behaves as though embedded in a massive invisible sphere, binding it together across immense distances. This unseen structure is one of the defining features of the Milky Way and of galaxies throughout the universe. Looking outward from the galactic center, the spiral disk gradually thins and fades. Star formation becomes sparse, and the glow of the arms diminishes. Beyond the visible edge lies a realm where only scattered stars and faint gas remain. Here, the Milky Way blends almost imperceptibly into the broader cosmic web, connected to neighboring galaxies by filaments of matter stretching across millions of light years. The Milky Way does not exist in isolation. It is part of a small gathering of galaxies known as the local group. Within this loose association, gravity binds dozens of galaxies together, ranging from large spirals to tiny dwarfs. They orbit a common center, interacting slowly over cosmic time. Some are already being drawn into the Milky Way, their stars destined to become part of its halo. One neighboring galaxy looms larger than all the rest. A massive spiral drifts steadily closer, its own disk filled with hundreds of billions of stars. Over billions of years, the distance between the two galaxies has been shrinking. Their eventual encounter will reshape both, stretching their disks into long tidal streams and igniting bursts of star formation as gas clouds collide and compress. Such a merger is neither rare nor catastrophic on cosmic scales. Galaxies grow by consuming others, evolving through repeated encounters. Though individual stars are unlikely to collide, the overall structure of the galaxies will change dramatically. Over time, their spiral forms will dissolve, replaced by a single, larger system with a smoother, more rounded shape. Long before that distant future arrives, the Milky Way will continue its slow rotation. Stars will complete orbit after orbit, nebulae will form and disperse, and the central regions will remain anchored by their immense gravitational core. The galaxy will carry on, shaped by forces that operate on timescales far beyond ordinary experience. From the faint outskirts to the dense heart, the Milky Way is a record of continual change. It is built from motion, from gravity, and from time itself. Every star traces a path laid down by ancient events, and every region reflects a balance struck between stability and transformation. The journey through this galaxy reveals not a static structure, but an evolving system, endlessly reshaped by the quiet persistence of cosmic forces. As the Milky Way drifts through the wider universe, it carries with it an internal rhythm set by rotation and gravity. The galactic disk turns slowly, completing a single revolution over hundreds of millions of years. Stars embedded within it move together in a vast, ordered flow, while those in the halo follow far more elongated and unpredictable paths. This layered motion gives the galaxy both stability and flexibility, allowing it to endure despite constant internal change. The oldest stars within the Milky Way formed not long after the universe itself emerged from darkness. These early stars were composed almost entirely of hydrogen and helium, lacking the heavier elements that would appear later. Their lives were brief and intense. When they ended, they seeded their surroundings with the first metals, enriching the gas from which later generations of stars would form. Every atom heavier than helium within the galaxy carries the imprint of these long-vanished suns. Over time, successive generations of stars increased the chemical complexity of the Milky Way. Planet-forming materials became more abundant. Rocky worlds became possible. The quiet outskirts of the disk, far from the crowded and irradiated spiral arms, provided a stable environment where planetary systems could persist for billions of years. These regions avoided frequent supernova and intense radiation, allowing long-term processes to unfold without constant disruption. This balance between chaos and calm defines much of the galaxy's character. The spiral arms, though visually striking, are regions of upheaval. Gas clouds are compressed, stars ignite rapidly, and massive suns burn out in violent explosions. Between these arms, conditions are far gentler. Older stars dominate, moving through space with steady regularity. It is within such a region that one particular planetary system developed, remaining largely undisturbed over immense spans of time. Even here, motion never truly ceases. The entire system drifts upward and downward through the galactic plane, oscillating slowly as it orbits the center. Over tens of millions of years, it passes through denser and thinner regions of the disk, subtly altering the cosmic environment around it. These gradual changes unfold too slowly to be noticed on human timescales, yet they shape the long history of the galaxy. Far beyond the disk, the halo continues to absorb material from its surroundings. Streams of stars arc inward as dwarf galaxies are gradually dismantled. Their stars disperse, blending into the halo and disk, contributing mass and momentum. Each merger leaves behind ripples in stellar motion that persist for billions of years, faint signatures of ancient encounters written into the galaxy's structure. At the largest scales, the Milky Way itself follows a path through space defined by the distribution of mass in the local universe. It moves toward regions of higher density, drawn by the combined gravitational pull of neighboring galaxies and dark matter concentrations. This motion is subtle but relentless, part of a grand cosmic flow that shapes the arrangement of galaxies across vast distances. As time advances, the galaxy will continue to evolve. Gas supplies will slowly diminish as stars form and lock material away. Star formation will decline, and the Milky Way will grow quieter. Its bright spiral arms will fade, leaving behind a population dominated by long-lived, faint stars. The central regions will remain active longer, sustained by material funneled inward over time, but even there, activity will eventually wane. In the far future, after countless orbits and transformations, the Milky Way will no longer resemble its present form. Mergers will have altered its shape. Stellar populations will have aged. Yet despite these changes, the galaxy will remain a coherent structure, held together by gravity and dark matter, carrying the accumulated history of everything that has ever been part of it. This vast system, stretching across tens of thousands of light years, is both dynamic and enduring. It is shaped by processes that began shortly after the birth of the universe and will continue long after individual stars have faded. To trace its structure is to follow a story written in motion and time, one that continues to unfold on scales far beyond ordinary experience. As the galaxy ages, its future becomes increasingly shaped by interactions beyond its own boundaries. The Milky Way is surrounded by a swarm of smaller companions, faint dwarf galaxies bound loosely by gravity. Many have already begun their slow descent inward, stretched into elongated streams as tidal forces pull them apart. Over time, these stars are absorbed, adding quietly to the growing mass of the halo and disk. One companion dominates this distant future more than any other. A large spiral galaxy approaches steadily, its stars and gas clouds tracing a slow, inevitable convergence. As the two systems draw closer, their outer regions will begin to distort. Long arcs of stars will be pulled from both galaxies, flung outward into space before falling back toward the merging core. These tidal structures will glow faintly for millions of years, visible markers of a transformation in progress. As the encounter deepens, gas clouds within both galaxies will collide and compress. New waves of star formation will ignite across regions that were once quiet. Massive stars will form in abundance, lighting the merged system with intense but short-lived brilliance. These bursts of activity will alter the chemical composition of the galaxy, enriching it further with heavy elements forged in stellar interiors. Despite the dramatic scale of such a merger, individual stars are unlikely to collide. The distances between them remain vast, even in the densest regions. Instead, gravity reshapes orbits, redistributing stars into a new configuration. Over time, the ordered spiral structure of the Milky Way will dissolve, replaced by a smoother, more rounded form. The result will resemble an elliptical galaxy, larger and more massive than either of its predecessors. During this long transformation, the central regions will become especially active. Gas, funneled inward, will feed the dense core, briefly increasing its luminosity. Energetic outflows may sweep through surrounding space, heating and dispersing remaining gas. Eventually, as supplies are exhausted, this activity will subside, leaving behind a quieter, older galaxy dominated by long-lived stars. Far from the center, the halo will expand and grow more diffuse. Its stars will trace broad, graceful paths around the merged core, carrying with them the memory of multiple galaxies combined into one. Dark matter will continue to provide the underlying framework, ensuring that the new system remains bound together despite its changing shape. Long after the merger is complete, the galaxy will enter a calmer phase. Star formation will become rare. The brightest stars will have burned out, leaving behind dim red dwarfs, white dwarfs, and the remnants of once massive suns. The night sky within such a galaxy would appear very different, less vibrant, yet still filled with countless points of light. Throughout this distant future, motion never fully ceases. Stars will continue their slow journeys around the galactic center. Clusters will gradually disperse. The faint glow of old stars will persist for trillions of years. Even as the universe itself expands and galaxies drift farther apart, this merged system will remain a gravitationally bound island, evolving quietly and quietly. Isolation. The Milky Way, from its earliest beginnings to its farthest future, is defined by continuity rather than permanence. Its form changes, its contents shift, yet its identity as a galaxy endures. It is a structure shaped not by sudden events alone, but by the steady accumulation of countless small influences acting over immense spans of time. Every stage of this evolution reflects a balance between creation and loss. Stars are born, stars fade, and the material they release becomes part of something new. The galaxy carries this cycle forward endlessly, reshaping itself while preserving the record of what came before. Beyond the long arc of its future, the Milky Way remains anchored in the present by forces that operate quietly and continuously. Gravity governs every scale of its structure, from the smallest clusters of stars to the motion of the galaxy as a whole. Nothing within it is truly still. Even regions that appear calm are threaded with slow movement, subtle shifts that unfold over spans of time far exceeding ordinary perception. The disk itself is not a rigid plane, but a gently warped surface. Tides from neighboring galaxies and the uneven pull of dark matter cause it to bend and ripple. These distortions travel through the disk like waves across water, altering stellar orbits and redistributing gas. Over millions of years, such motions subtly reshape the galaxy, adjusting its structure without dramatic disruption. Embedded within the disk are vast clouds of molecular gas, cold and dense compared to their surroundings. These clouds drift along the spiral arms, compressed by passing density waves. Within them, pockets collapse under gravity, forming new stars that emerge shrouded in dust. Their earliest light is hidden, revealed only when radiation clears the surrounding material. This process repeats continuously, sustaining the galaxy's slow renewal. Not all matter follows the ordered rotation of the disk. High-velocity stars streak through the galaxy on unusual paths, moving far faster than their neighbors. Some were accelerated by close encounters with the central regions, flung outward by gravitational interactions of extraordinary strength. Others arrived from outside entirely, remnants of galaxies long since absorbed. Their trajectories add complexity to the galactic flow, reminders of violent events now largely erased. Above and below the disk, faint structures extend outward like vast curtains. These are regions where gas flows between the galaxy and its surroundings. Material falls inward from intergalactic space, while energetic outflows push gas outward, driven by stellar winds and past activity near the core. This exchange connects the Milky Way to the wider universe, ensuring it is not a closed system, but part of a larger cosmic circulation. At the smallest scales, stars themselves are not permanent fixtures. Over time, they drift apart from their birth clusters, dispersing into the general population of the disk. The galaxy slowly mixes its contents, blending stars of different ages and origins. This gradual stirring smooths out differences, creating the broad, continuous distribution seen today. Even the most enduring structures show signs of change. Globular clusters lose stars through tidal stripping as they orbit the galactic center. Stellar streams lengthen and fade. The central regions shift as mass moves inward and outward. Each process operates slowly, yet together they drive the long-term evolution of the galaxy. Through all of this, the Milky Way remains governed by balance. Too much disruption would tear it apart. Too little would leave it stagnant. Instead, it exists in a state between these extremes, dynamic yet stable, changing yet recognizable across billions of years. The journey through the Milky Way reveals not a single moment frozen in time, but a system caught in perpetual motion. Every region reflects a different stage of an ongoing story, shaped by forces that act patiently and persistently. This continuity is what allows the galaxy to endure, carrying forward its history even as its form slowly transforms. As attention shifts from structure to scale, the full immensity of the Milky Way becomes more apparent. The galaxy spans a distance so large that even its own stars rarely complete many circuits within a single lifetime. A star like the Sun requires hundreds of millions of years to make one slow orbit around the galactic center. In that time, continents shift, species rise and vanish, and entire chapters of planetary history unfold unnoticed against the backdrop of galactic motion. This immense timescale gives the Milky Way a kind of patience. Events that seem sudden within human experience are brief ripples here. Supernova flare and fade. Star clusters form and disperse. Gas clouds collapse, ignite, and thin out again. Each cycle leaves subtle traces, layered upon those left by countless cycles before. The galaxy becomes a record not of moments, but of processes repeated across deep time. Because it is observed from within, understanding the Milky Way has always required indirect methods. Its shape, mass, and motion are inferred from the behavior of stars and gas, from faint radio emissions, and from careful measurements of movement across the sky. The galaxy reveals itself not through a single image, but through patterns that emerge only when vast amounts of data are assembled and interpreted. This limitation has shaped the way the Milky Way is understood. No observer can step outside it to see its full form. Every map is a reconstruction. Every spiral arm is traced by distant signals and motion rather than sight. Yet these reconstructions converge on a consistent picture, a barred spiral galaxy with sweeping arms and a dense, dynamic core embedded in a massive halo of unseen matter. Within this structure, scale repeats itself in subtle ways. Small clusters resemble larger groupings. Spiral arms echo patterns seen in faraway galaxies. The same physical laws shape stars, star systems, and galaxies alike. Gravity draws matter together. Motion distributes it. Energy transforms it. Across every level, the Milky Way follows principles that apply throughout the universe. This universality gives the galaxy broader significance. It is not an anomaly or an outlier, but a representative example of a common cosmic form. Many galaxies share similar sizes, shapes, and histories. By understanding this one in detail, insight is gained into countless others scattered across the observable universe. Yet familiarity does not diminish its depth. Even now, fundamental questions remain unanswered. The true nature of dark matter is still unknown. The precise history of early galactic mergers continues to be refined. The behavior of the central regions under extreme gravity remains an active area of study. Each answer reveals new layers of complexity rather than closure. As the journey nears its later stages, what stands out most is not any single object or region, but the coherence of the whole. From faint outer halo to crowded inner core, the Milky Way functions as a unified system. Its parts are linked by gravity and motion, by shared history and common origin. Nothing exists in isolation within it. This coherence allows the galaxy to persist across vast stretches of cosmic time. While individual stars are born and lost, the galaxy remains, slowly evolving yet continuous. It carries forward the material and momentum of everything it has ever absorbed, reshaping itself without forgetting what it has been. To trace the Milky Way is to follow an unbroken thread from the earliest epochs of the universe to a far distant future. It is a structure shaped by time more than by any single event, a system defined by endurance as much as by change. The journey through it reveals a galaxy that is immense, dynamic, and quietly persistent, unfolding its story across scales that stretch far beyond ordinary experience. Beyond its visible boundaries, the influence of the Milky Way extends farther than light alone would suggest. The faint outer halo, populated by sparse stars and streams of ancient debris, blends gradually into the surrounding intergalactic medium. Here, the density of matter drops to almost nothing, yet gravity still exerts control. Even in these remote regions, the galaxy's presence is felt, guiding motion across distances so large they defy intuition. This extended reach reveals an important truth. A galaxy is not defined solely by what can be seen. Its true size includes everything bound to it, including vast amounts of dark matter and tenuous gas stretching far beyond the luminous disk. The visible stars mark only the brightest concentrations within a much larger structure, one whose edges are difficult to define with precision. Within this structure, time continues its slow work. Orbits precess. Stellar streams spread and fade. The memory of past mergers becomes increasingly diffuse, yet never entirely erased. Each interaction leaves behind subtle distortions, faint echoes of encounters that occurred billions of years ago. By studying these patterns, the long and complex history of the Milky Way can be reconstructed piece by piece. The galaxy's motion through space adds another layer to this story. It does not drift randomly, but follows a path shaped by the distribution of mass in the surrounding universe. Nearby galaxies tug gently upon it. Dark matter concentrations influence its trajectory. Together, these forces guide the Milky Way along a slow arc through the cosmic web, connecting it to structures far beyond its immediate neighborhood. As this motion continues, the universe itself expands. Distant galaxies recede, carried away by the stretching of space. Over immense spans of time, the Milky Way and its nearest companions will become increasingly isolated, bound together while the rest of the universe slips beyond Praz. Reach. This isolation will mark a new phase in the galaxy's existence, one defined by internal evolution rather than external interaction. In such a future, the night sky within the galaxy would appear quieter. Fewer bright stars would form. The glow of nebulae would fade, yet motion would persist, slow, and steady. Stars would continue to orbit the center. Remnants of long dead suns would accumulate. The galaxy would settle into a long, gradual aging process, changing subtly rather than dramatically. Despite this eventual quiet, the Milky Way's past remains rich and dynamic. Its structure bears the imprint of countless events, from early collapses of primordial gas to violent mergers with other galaxies. Each phase added complexity, shaping the galaxy into the form observed today. The present moment is only one frame in a vast sequence extending across nearly the entire age of the universe. This continuity is one of the galaxy's defining characteristics. While individual stars live and die, the Milky Way endures. It absorbs change, redistributes matter, and adapts its structure without losing coherence. Its identity is not fixed to a single shape or era, but to the ongoing process of evolution itself. Tracing this process reveals a galaxy that is both immense and intimate. It is vast enough to contain hundreds of billions of stars, yet structured by the same physical laws that govern the smallest systems. Gravity, motion, and time link every region together, creating a single, interconnected whole. As the journey through the Milky Way approaches its later stages, the emphasis shifts from exploration to perspective. The galaxy is no longer just a collection of regions to pass through, but a continuous environment shaped by deep time. Every star, every cloud, every faint halo stream contributes to a structure that is far larger than any one part. The Milky Way stands as a reminder that scale and duration are central features of the universe. Processes unfold slowly, yet relentlessly. Change accumulates quietly. What appears stable is often the result of countless subtle motions acting together over immense spans of time. In this way, the galaxy embodies the rhythm of the cosmos itself, steady, patient, and unending. As the Milky Way continues its slow evolution, its internal motions gradually smooth out the sharp contrasts that once defined its structure. Spiral arms that were once vivid with newborn stars become less distinct as star formation slows. Gas reservoirs thin, consumed or dispersed over billions of years. The galaxy does not stop changing, but the nature of its change becomes quieter, more subdued. The brightest eras of stellar activity pass early in a galaxy's life. What follows is a long twilight phase, dominated by small, faint stars that burn their fuel with remarkable efficiency. These stars may persist for trillions of years, far longer than the current age of the universe. Their steady glow becomes the dominant source of light within the galaxy, long after massive stars and brilliant nebulae have faded from view. During this extended epoch, the Milky Way becomes increasingly uniform. The distinctions between disk and halo soften as stellar orbits mix and redistribute. Remnants of ancient mergers stretch into ever thinner streams until they blend into the background population. What once appeared chaotic resolves into a smoother, more evenly distributed system. At the center, the dense core remains a focal point of motion. Stars continue to pass close to the central mass, tracing tight, rapid orbits. Yet even here, activity diminishes over time. With little gas left to feed energetic processes, the core settles into a quieter state. The immense mass at the galaxy's heart persists, shaping motion without spectacle. The galaxy's identity shifts from one defined by active transformation to one defined by endurance. Its remaining stars follow predictable paths, completing orbit after orbit with little interruption. Clusters slowly evaporate. Stellar remnants accumulate. The Milky Way becomes a repository of long-lived objects, carrying forward the accumulated outcome of all earlier stages. Beyond the galaxy itself, the universe continues to expand. Distant galaxies fade from view as space stretches between them. The Milky Way and its closest companions remain bound together, forming an isolated island of matter in an increasingly empty cosmos. Within this island, change continues, but external influences diminish. This isolation marks a profound transition. The early universe was a place of frequent encounters, collisions, and growth. The far future belongs to systems that evolve largely in solitude. The Milky Way moves gradually into this latter phase, shaped less by interaction and more by the slow internal redistribution of its own contents. Through all these changes, one feature remains constant. The galaxy endures as a single gravitational system, maintaining coherence across spans of time that exceed ordinary comprehension. Its stars, though individually transient, collectively form a structure that persists far longer than any one component. What emerges is not a static remnant, but a mature galaxy, altered by time, yet still complete. Its form may differ greatly from its earlier spiral appearance, but its continuity remains unbroken. The Milky Way carries forward the record of everything it has absorbed, transformed, and retained. As the Milky Way carries on through deep time, its changes become increasingly subtle. The dramatic phases of formation and collision fade into the background, replaced by processes that unfold so slowly they blur into continuity. Stars continue to orbit the galactic center, but their paths are smoother now, less frequently disturbed by fresh infusions of gas or by close encounters with Kaka. Neighboring galaxies. The galaxy becomes quieter, not empty, but settled. Within this long calm, the remaining stars define the character of the Milky Way. Small, cool stars dominate the population, their faint light steady and enduring. They burn their fuel so slowly that they persist for spans of time far longer than the galaxy's early, more violent eras. Around some of them, planetary systems remain intact, drifting through space long after the environments that once shaped them have disappeared. The remnants of earlier generations become more prominent. White dwarfs cool gradually, fading toward invisibility. Neutron stars continue their slow rotations, relics of supernova that once briefly outshone entire regions of the galaxy. Black holes move silently along their orbits, detectable only through their gravitational influence. These objects do not announce themselves, yet they carry the memory of the Milky Way's most intense epochs. The structure of the galaxy becomes harder to define by light alone. Without bright spiral arms or active star-forming regions, its shape must be traced through motion. Stellar orbits reveal the presence of mass where little light remains. The dark matter halo continues to dominate the galaxy's overall form, ensuring that stars remain bound even as visible features fade. Over immense timescales, the distinction between different galactic components softens. The disk thickens as stellar orbits slowly spread. The halo becomes more diffuse as streams of stars stretch and dissolve. What was once clearly divided into arms, bulge, and outskirts gradually transitions into a smoother distribution. The Milky Way does not vanish, but it becomes simpler. Despite this simplification, the galaxy remains dynamic. Gravity never rests. Stars exchange tiny amounts of energy during distant encounters. Orbits shift imperceptibly. Matter drifts inward toward the center and outward toward the halo. Each change is minor on its own, yet together they continue to reshape the galaxy long after its brightest era has passed. In this phase, the Milky Way stands as a mature system. Its form reflects a long balance between accumulation and loss, between motion and stability. The dramatic events that once defined it are now embedded deep in its structure, detectable only through careful study. What remains visible is the result of everything that came before, preserved not as memory, but as motion. As the universe continues to expand, the Milky Way's broader context changes profoundly. Galaxies beyond its immediate neighborhood drift farther away, their light stretched and weakened by the growth of space itself. Over time, many recede beyond any possible contact, leaving the Milky Way and its bound companions increasingly isolated. What was once a universe filled with countless visible galaxies becomes, from within this system, a far quieter place. This isolation does not alter the galaxy's internal rhythm. Stars continue their long orbits. Stellar remnants persist. Dark matter maintains the galaxy's cohesion. Yet the absence of external interaction marks a turning point. The Milky Way transitions from a participant in a crowded cosmic environment to a largely self-contained system, evolving according to its own internal soul. Processes alone. Within this isolated future, the galaxy becomes a kind of archive. Every star, every remnant, every diffuse cloud of gas holds information about earlier cosmic eras. The chemical composition of stars reflects generations of stellar evolution. Orbital patterns preserve evidence of ancient mergers. Even the distribution of dark matter encodes the history of formation and growth. Over unimaginably long periods, complexity continues to give way to endurance. Star formation dwindles further as usable gas is exhausted or locked away. The remaining stars age slowly, their light fading but not disappearing. The galaxy enters a prolonged twilight, one defined not by sudden endings, but by persistence. Yet even this twilight is not static. Motion remains fundamental. Orbits precess. Remnants drift. Energy continues to redistribute, however gradually. The Milky Way does not freeze into a final form. It continues to evolve, shaped by gravity and time, long after the universe has lost much of its original structure. Seen across its full lifespan, the Milky Way is not defined by any single moment. It is defined by continuity. From its earliest collapse out of primordial matter, through eras of violent growth and luminous complexity, and into a distant future of quiet endurance, the bar galaxy follows a single, unbroken trajectory. This journey reveals a deeper truth about cosmic structures. They are not built to last unchanged, nor are they destined for sudden disappearance. Instead, they persist by transforming, gradually adjusting to the conditions imposed by time and scale. The Milky Way exemplifies this process, carrying forward its identity even as its appearance shifts. In the end, the galaxy stands as a testament to duration. It is shaped less by individual events than by the accumulation of countless small changes. Gravity binds it. Time reshapes it. Together, they allow a structure vast beyond ordinary experience to endure across nearly the entire history of the universe, continuing quietly, orbit by hour. Orbit, long after its brightest moments have passed.